Okay, we're on to problem 64 on page 409. This is a sister to problem 68, and in all cases, this set of problems, it's really worth a while you spending some time here. It takes a little time to start to get comfortable with these problems. You're given a graph, you're asked to write a function or an equation for that graph. There's a couple of different answers that we could write down that are right. And that owes to the fact, again, that the sine and the cosine are really the same graph. They are just slid. You're going to call this sliding in phase relative to one another. Right? The cosine, in some sense, is behind the sine by 90 degrees. But that aside, let's just maybe take this on in as straightforward a manner as we can. This is a sine or a cosine function. We're going to start to refer to such functions as sinusoidal. But let's just say y is equal to some constant that changes the amplitude, because the amplitude of the sine is 1 and this one's 2, times the sine of some number times x. And now let's just reason through what these numbers might be. Let's start with the easy one is the amplitude, right? Because the amplitude of the sine is 1. It goes from a maximum 1 to a minimum minus 1. This particular case is going from a maximum of 2 and a minimum of minus 2. We're going to just write that down by symmetry. And so we're going to say, hey, A is equal to 2, and then it's kind of by inspection, right? We're just going to look at the graph and see that. And so therefore, y is equal to 2 times the sine. Well, it's not quite. I'm sorry. Let me say that by inspection. But the other problem here is that, the other issue here is that the sine of x, starts at 0, 0 and goes up. Whereas this graph starts at 0, 0 and goes down. So the sine has been flipped around the x-axis, which is what happens when you multiply by a minus sign. So if that's the case, I'm having a little trouble documenting this. I'll just say since the graph starts down rather than up, write it like this. Okay, so the amplitude here we go. I'm just now figuring this out as I'm going along. By inspection, the amplitude is 2. And since the graph starts down rather than up, A must be equal to minus 2. All right, so we're looking at y is equal to minus 2 sine kx. And we can deal with kx pretty quickly, okay? Let's look at this point right here. Note, this is the first zero crossing after the origin. And for y equals sine of x, that occurs when x is equal to pi. Right here, it's occurring when x is equal to 2. So there's been a compression, right? Which means that we've multiplied x, or we've replaced x with a constant times x where that constant is greater than 1. What is it? Let's just say at x equals 2, the first zero crossing occurs. And that happens when the argument is equal to pi. So what that means is kx is what that means is when x is equal to 2, kx is equal to 2 times k, and it has to be equal to pi, which says k is equal to pi over 2. And so if we just throw that back up here, we're going to say, therefore, y is equal to minus 2 sine pi over 2 times x. We're going to do a quick check. If I put in x is equal to 4, pi over 2 times 4 is 2 pi. Sine of 2 pi is 0, and sure enough, I've got a 0 crossing again here at 0. If I put in x equals 1, then I've got sine of pi over 2. Sine of pi over 2 is 1, multiplied by minus 2 is minus 2, and sure enough, I've got that point right there. So I think we've got the right answer in this case.